Hi everyone, you are welcome to DML Physics Concepts. Kindly subscribe to this YouTube channel, like our video, and make comments in the comment section. Alright, today we will continue from where we stop and we'll be looking at resistance in series and parallel in a circuit. So when resistors are arranged in a circuit, the first thing you need to understand is you must know if the arrangement is a series arrangement or a parallel arrangement. So how do we know that a kind of arrangement is a series arrangement? Now, it's a series arrangement when we have it like this. And how do we know that it's a series arrangement? What I usually do is, I'll tell students is that normally when resistors are arranged in a circuit, the purpose is that current should flow through them. And current will always flow from the cell, which is the source. So let's just trace it like this. So when current flows from the cell, it passes through this place. This is the part of the flow of current, which is the circuit. So the current flows from the cell. It flows from the cell. It enters the first resistor. Directly it enters into the second resistor. Directly current enters into the third resistor before the cycle completes like this. So in the case we have a situation whereby current flows through all the resistors in the circuit without breaking in parts. That is, it flows directly like this. Then what we are having is called a series connection. So that's what we call series connection. So in a series connection, the concept is very simple. You must understand this concept. The same current flows through the resistors. The same current that flows from the source, the same current flows through R1, the same current flows through R2 and R3. But the second concept you must understand is that but voltage across each of the resistor is different. So in summary, when resistors are connected in series, they have the same current, but their voltage is different. So you have to put that at the back of your mind. Now when resistors are arranged in series, they have the same current, but their voltage is different. And how do I know that in series? When current flows from this source, it flows directly into R1, into R2, and directly into R3. But let's look at this kind of connection. So when current flows from the cell here, and the current flows, when the current gets here, so this is the resistors. So when current gets here, the current cannot enter here without splitting at this point. So for current to enter into R1, R2, R3, current must split into 3 because you have 3 resistors. So at this point, current will split into 3. A part of the current will flow through R1, part of it will flow through R2, part of it will flow through R3. So when they flow out, they come out here and combine again, and then the circuit continue. So in a situation whereby current have to split before it can pass through all the resistors in that circuit, then we can say the arrangement of that resistors is a parallel arrangement. I believe that is clear. So the concept you need to understand in this part is that you discover that current splits. So therefore they have different currents but the same voltage. So the concept is clear. For a series current, for series circuits or series connection, they have the same current, different voltage. But for a parallel connection, they have different current but the same voltage. So that concept is what we are going to use to determine the equivalent resistance in a circuit. What do I mean by equivalent resistance? That is the overall value of resistance in a circuit. In this case, we have R1, R2, R3. If I want to know the value of the total of the 3 resistance together, then I need a formula. And how do we generate the formula? We generate the formula using this concept I explained. And what's the concept? In a series circuit, I is the same, but V is different. So let's quickly prove this formula very fast now. So since we said that their V is the same, is different, then it means the total V, the total voltage of this circuit, the total voltage of this circuit equals to V1 plus V2 plus V3. It's just that V splits into 3. So we are going to have V equals to V1 plus V2 plus V3. So in that case, let's go into Ohm's law. Since in Ohm's law we said V equals to IR in Ohm's law. So let's substitute V equals to IR into this equation. So for V is going to be IR equals to V1. For V1 is going to be IR1, not I1 R1. Why is it not I1 R1? Because the same high flows through the 3 of them. They have the same high. So it's still high, but the resistance is different. So we are going to have I R1. For this one, we are going to have I 2. And for the third one, we have high R3. So the next thing we need to do is to factorize. So let's factorize this one with high. So we are factorized with high. We are going to have, if we are factorized with high, so we are going to have I into bracket R, I, high into bracket R1 plus R2 plus R3. So we are going to have high into bracket R1 plus R2 and R3. So let's divide both sides by high. So we are divide both sides by high. We are going to have our final formula, which is R. The total R is going to be R1. So depending on the number of resistors we have in a series connection, we find the total resistance in that circuit by adding those resistors together, like saying R1 equals to R2 plus R3. So if you have more than 3, just say R1, R2, R3 onto the last numbers of resistors that we have in that cycle. So we don't need to cram this formula, just understand the concept that in a series connection, the current is the same, the voltage is different, and since the current is the same, then we have, since the voltage is different, we say V equals to V1 plus V2, and from there we prove using Ohm's law, and we arrive at this formula. So let's look for the case of the series connection and see how we arrive. We are going to arrive at the formula for finding these equivalent resistors too. So for a parallel connection, when current flows, it splits into 3. So the current is different, but they have the same voltage. So because the current is different, then it means the total current here equals to high 1 plus high 2 plus high 3. The total current equals to high 1 plus high 2 plus high 3. The high split into 3, then later it comes back, then the circuit completes. So the total high equals to high 1 plus high 2 plus high 3. Now, let's apply Ohm's law. Since Ohm's law states V equals to high R, therefore high equals to V over R. So if I is V over R, then you can now substitute into this equation. So we want to substitute in the equation for this total high is going to be V over R. That is the total V. Remember the V is the same. Total V, total R, because we want to look for total R. So this is the total high. So we are going to have V and total R. That is total V, total R. For the high one, we are going to have V R1. We are not going to have V1 R1. No. We are not going to have V1 over R1. Why? Because the V is the same for the circuit. The V that is here is still the V across here. So the V here is also the V here, is also the V here. So there is no point saying V1, V2, V3. It's the same V. All the V are the same. But the resistance are different. We have R1, we have R2, and R3. So for high 1, we are going to have V over R1. For the high 2, we have V over R2. While for the high 3, V over R3. So now that we have the V like that, let's factorize this one. Factorize the V because V is common. They have the same V. So let's factorize with V and let's see what we have. So if you factorize with V, we are going to have V into bracket 1 over R1 plus 1 over R2 plus 1 over R3. I always tell my students you need to be versed in mathematics to be able to understand physics. Some students don't even know how to factorize, but factorize simply means just make V is common. It's a factor that is common for the 3. So you just take it out and then you write the rest. So let's divide both sides by V. If I divide both sides by V now, so V eliminates V, then we are going to have so we are going to have 1 over R1 equals to 1 over R2. 1 over R is going to be 1 over R1 plus 1 over R2 plus 1 over R3. So if I want to add the resistance in a circuit like this, then the equivalent resistance is given by 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. Alright, before we conclude this class, let me just do 2 examples. One for series connection, one for parallel connection. Then we can also do one for combination of the series and parallel connection. So let's quickly look at example 1. So let's look at this example 1. The question is, find the equivalent resistance in the circuit, in this circuit. That is, what is the total resistance of this particular circuit? So let's say circuit, this is the path of flow of current. So what's the value of the total resistance in this circuit? The next thing you need to ask yourself is this kind of connection a series connection or a parallel connection? So you will say series connection, some will say parallel connection, but let's look at it before we conclude. A series connection is such a connection whereby when current flows through all the circuit without splitting, all through the resistors without having to split. So let me start from a point. Let's just assume that current is starting from this point, or you can decide to start from any of these points. So let me start from point here. So if current flows like this, it flows like this, then it flows like this, then it flows like this. So if you look at it very well, you discover that current flows through the three resistors without having to split to different parts. It has to move. So the same current will flow through this resistor. Because the same current will flow through this resistors, then we can say this is a series connection. So for series connection, what formula do we use? So for series connection, let's recall that R equals to R1 plus R2 plus R3. So if this one is R1 and this one is R2 and this one is R3, so our total R is going to be, so it's going to be 3 plus 2 plus 3. And what's 3 plus 2 plus 3? That's going to be 8 ohms. So in these connections, then the equivalent resistance in this circuit is 8 ohms. Let's look at example 2 where we have a parallel connection. So let's look at this example 2. So we are also asked to find the equivalent resistors or resistance of this circuit. That is, equivalent is talking about the total resistance of this circuit. So we want to also know, is this a series connection or a parallel connection before we assume the formula. So let's look at it. So let's pick a point that current is flowing from somewhere. So it's flowing from this point. And when current gets to this point, current cannot enter this without not splitting into 3. So the current will have to split to flow this resistor 1, then flow this resistor 2, and flow through resistor 3. So because current have to split into 3, it means they are having different current. So current is not the same. Current splits here, then later come back. So it splits. Because it splits, they don't have the same current. And therefore, when a circuit does not have the same current, when resistors does not have the same current flowing through them, then we say those resistors, they are in parallel. So for parallel connections, so let's look at what is going to be our formula. Our formula is going to be, so it's going to be 1 over R total, that is the total R we are looking for, equals 1 over R1 plus 1 over R2 plus 1 over R3. So let's substitute. So if this one is going to be our R1, this one is going to be our R2, this one is going to be our R3. So we are going to have, so we are going to have 1 over 3 plus 1 over 2 plus 1 over 3. So we can just solve from here and find the LCM. So find the LCM of this value, which is 6. So the LCM is 6. That is 6 divided by 3, that is 2. 2 times 1, that is 2. Then 6 divided by 3, that is 3. 3 times 1, that is 3. And the same thing here is going to give us 2. So we are going to say 1 over R total. So 1 over R total is going to give us, that is 7 over 6. So 1 over R total is going to be 7 over 6. So if 1 over R theta is 7 over 6, remember 7 over 6 is not the result. 1 over R total. But what we're looking for is R total, but not 1 over R total. So what we just do is, you can cross multiply. So by cross multiply, we are going to say 7RT equals to 6 times 1. I'm doing it like this because of some students that may not be able to understand straightforward like that. So 7RT equals to 6 like that. Then we now say the R total is going to be 6 divided by 7 ohms. So it means the equivalent resistance in this circuit is simply 6 divided by 7 ohms. And 6 divided by 7 ohms, we want to use calculator just to solve further. We are going to have 0.86. So it's going to be, R total is going to be 0.8, I think 0.86 ohms. It should be around that value. 0.86 ohms. So this is going to be our equivalent resistance. So all these resistors, when they are in parallel and I add it together, it's going to give me 0.86. But when they are in series and I find their total resistance, is going to give me 8 ohms. Now let's look at the third examples before we round up, in case where we have combination of series and parallel connection. So let's look at this example 3. If you look at this now, some students will get confused and look at, is this one series, is this parallel? They won't be able to know. But let's look at it. The concept is very simple. You don't need to worry yourself. The point thing you need to know is that where is current flowing? This is a part of flow of current, and you must know that current must flow from somewhere. And when current flows from somewhere, what to put at the back of your mind is that whenever current have to split, then it means every resistors in that and every resistors through which current flows and there is a splitting of current, those resistors they are parallel to each other. So let's trace from any point. So let's say we start from this point. We can start from this point. So let's say this current is moving. When the current gets here, part of the current will flow here, part of the current will flow here. Are you following? Now, part of the current will split at this point. Part of the current will flow here, part of the current will flow here. Now, the part of the current that flows here flows through this one, flows through this one, flows through this one before it splits again. So which means when the current moves here, part of it flows here. The other part that flows here, the other part that flows here, flows through this, flow through this, flow through this. So which means 2, 4, and 5, they are series to each other. 2, 4, and 6, they are series, because once this current split, the one that passes through 2 passes through here, passes through here. So what we are going to have is that, so when we have our high that is coming, we are split into high 1 and high 2. Why the high 2 is the summation of this high. So let's add these 3 together first to know the equivalent resistance for these 3. Let's sum this one and make it 1. So we are going to make it, because they are series in connection, we are going to have remember, if you want to add resistors in series, we use this formula. So we are going to have 2 plus 4 plus 5. And 2 plus 4 plus 5 is going to give us what? 11 ohms. So it means the total resistance in this circuit is 11 ohms. So what we are going to do is that we are going to reduce these 3 into 1, because the 3 together represent 11 ohms. So you can decide to redraw this diagram. Let's redraw this diagram to simplify this chart. So let's look at it now. This chart has been simplified to this point. Remember, this is the 1 ohm, this is 1 ohms, this is the 6 ohm, this is 6 ohms, this is the 3 ohms in between. But this 3 together has been reduced because we have added it up to have 11 ohms. So that's why we have 11 ohms here. So we have simplified it. So let's start again. Let's start again from here. So when current flows here, when the current gets here, the current have to split into this part and other part through this part. So this one and this one, that is this 3 ohms and this 11 ohms, they are parallel to each other. When current is coming from the source, when it gets here, it splits into this place and the other part flow through this place. So since the current has split here, so it means this one and this one, they are parallel to each other. So because they are parallel in each other, let's combine this also. Let's add it together to have a parallel, the equivalent resistor for this parallel combination. So we are going to use our formula now to add. You know, when we want to add, and in a parallel connection, we are using 1 over R1 equals to 1 over R2. 1 over R equals to 1 over R1 plus 1 over R2. So let's write that. So we are going to have 1 over R equals to 1 over R1 plus 1 over R2. Though what do I use? Why do I use 1 over R1 and 1 over R2? And I didn't use 1 over R3? Because we are dealing with just 2 resistors. So we have 1 over R equals to 1 over R1 plus 1 over R2. Hereby R1 is 3 and R2 is 11. So let's substitute here. So when I substitute, I'm going to have 1 over 3 plus 1 over 11. So let's find the LCM. The LCM is 33. So let's say 3 and 33, that is 11. 11 times 1, that is 11. And 33 in 11, that is 3. 3 times 1, that is 3. So 1 over R is going to be 14 over 33. So that's going to be 1 over R theta. And what's now going to be our R value? We cross multiply. So our R total, the total resistance for this one is going to be 33 over 14. So 33 over 14, we can decide to simplify it further. And we may decide to leave it. We may not need to simplify further. We may decide to just leave it as. So total R is going to be 33 over 14 ohms. So it means the combination of these two resistors is going to give me 33 over 14 ohms. 33 over 14. So let's simplify this chart again. Let's simplify this diagram again. If you want to simplify, then it's going to look like this. So if you simplify this chart, we are going to have this. Remember, these two has been combined to give us 33 over 14. So let's look at this again. This is our 1 ohms. This is our 1 ohms. These two has been combined into this, and then we have our 6 here. So initially we start from here, we break it down, and then we are now here. So finally we now discover that we have a series connection. If you look at it, current and flow, we have a series connection. So finally, how do we find our total resistance here? We are going to say R equals to R1 plus R2 plus R3. So let's put it at this side now. So whereby our R1 is 1, our R2 is 33 over 14. That 33 over 14, okay, let's just simplify it so that we can make our work very simple. So 33 over 14 is going to give us something, I think 2.4. Let's approximate to 2.4. While our R3 is going to be 6 ohms. So let's add it together. So we are going to have 9.4. So our total resistance of this circuit, so our total resistance is 9.4 ohms. So that's our total resistance. So as we have this circuit like this, the overall resistance in this circuit is 9.4 ohms. Please, you have to check through again and just go through it. And if you have any question, you can ask your question. Thank you for joining this class. You can subscribe to this YouTube channel, turn on the notification bell. Thanks, and God bless you.